For these problems, give it a try before you continue the video. Now that you have tried these problems, you can actually look at the solutions over here. Now for the first one, we start off with a denominator doesn't equal to 0, so we have x squared minus 9 doesn't equal to 0. Here you can either use the difference of squares to do the factoring, or you can use a square root property. And I'm going to use the square root property since we have been doing factoring a lot, but not the square root property as much. So I'm going to add 9 on both sides, so I have a perfect square of the variable on the left. And here we can take the square root of both sides. Make sure you take both positive and negative roots. So therefore we get x is equal to plus or minus 3. And you should get the same result if you were to use the difference of squares and factor it out. You should get 2 results. And because of this, that's going to be the domain restriction. You can also use interval notation to represent it, or the set builder notation. I'm just going to write it here just in case you want to check your answer here. Then once we have this form, we want to state the vertical asymptote. Again, we don't have any simplification to do, so we would have the vertical asymptote to be x equals 3 and x equals negative 3. Sorry, I keep hitting the keyboard to create this random numbers over here. Now moving on to part B, we want to look at the denominator. Again, we want 2x squared plus 8x plus 3 to be not equal to 0. And for this process, we'll have to try the AC method for factoring over here. And if we do the a times c, we get 2 times 3, which is equal to 6. And we want the sum to be equal to 8 over here. So we're thinking about the product being 6 and sum equal to 8. And if you have tried it, you will see that we actually don't have any factor pairs of 6 that would give us a sum equal to 8, because it's either 1 times 6 or 2 times 3. Neither of them give us a sum of 8. That means we would actually have to use the quadratic formula over here. And to use a quadratic formula, we have to essentially set things up a little bit over here. I'm going to make more room for it. And to find the x value, we want to use 2a in the denominator, negative b plus minus square root of b squared minus 4ac. And negative b here is negative 8 plus minus square root of b squared, which is 8 squared, minus 4 times 2 times 3. And this is all over 2a, which is 2 times 2. And under the square root, we have 64 minus 24, which is square root of 40 over 4. And again, I'm going through the arithmetic somewhat quickly since you have already given it a try over here. And now for square root of 40, we can write it as 2 root 10, because it's square root of 4 times square root of 10. Square root of 4 becomes 2. And this is all over 4. And if we want to simplify it, we see that every term has a factor of 2. So we can say that x is equal to negative 4 plus minus root 10 over 2. So we're dividing each term by 2 to reduce the fraction a little bit. And that's going to be our domain restriction. Actually, x doesn't equal 2 for all of these, right? Because we want the result to be not equal to 0. So that's going to be the domain restriction. And as a result, for vertical asymptote, we would have x equals negative 4 plus root 10 over 2, and x equals negative 4 minus root 10 over 2. So these are the vertical asymptotes we get. Moving on to part C, we want to do a similar strategy by starting off with denominator not equal to 0. X squared plus 6x minus 72 cannot be equal to 0. And again, we want to think about whether factoring works. In this case, it should. And we would get x plus 12 times x minus 6, because 12 and negative 6 multiply to be negative 72, and 12 plus negative 6 gives us positive 6 as a sum. So we want this to be non-zero, so x plus 12 doesn't equal to 0, and x minus 6 doesn't equal to 0. Make sure you use and over here as a condition. So x doesn't equal to negative 12, and x doesn't equal to 6. If you want the interval notation, you can go negative infinity to negative 12, union negative 12 to 6, union 6 to infinity as a result. And for vertical asymptote, again, since we don't have any simplification, we get x equals negative 12 or x equals 6 are the, or and x equals 6 are the vertical asymptotes. And lastly, for part D, we start off with setting denominator doesn't equal to 0. And right away, I hope you recognize if we have a square term and plus some number, we should always have this result being positive, because 3x squared is non-negative, it's at least 0 or larger, and adding 9 would always make it positive. So we'll know it by default it's never going to be 0 anyways, so there's no domain restriction, so the domain is all real numbers using the set notation, or you can use the interval notation for negative infinity to infinity. And for vertical asymptote, we would say there is no vertical asymptote.